Hi guys, I think the course is going well. So we started with Chat GPT clone, then we did GitHub, then we did continuous integration, then we did prompt engineering, then we did Hugging Face, then we did AI automation. And I think the videos have been short. We are covering topics in good depth. So the idea is not to go super deep because you don't need super deep knowledge, right? Super deep knowledge is only required in areas where you would work in industry. Okay, so to crack a job or to get into the industry, this much knowledge is enough. Rest, whenever you face a use case, you tend to build on top of that. So now we'll be moving towards RAG. I guess one topic, that is continuous deployment, was left. I'll try to come up with an interesting use case for that in terms of Azure, so we'll see. And now we are talking about RAG. So guys, even if you more or less cover RAG and fine tuning, essentially you know a lot about AI engineering. Then it's a lot about experimentation and finding your niche and finding your use case. And RAG is probably one of the most important things that you would use, and it's very simple. You don't need to know so many things at base level. It's just use case to use case, but we'll cover everything at a good level today. So guys, see, what is RAG? Okay, RAG stands for retrieval augmented generation. Okay, so I'm going to read from here only. So RAG is a technique for augmenting LLM knowledge with additional data. I'm not sure how many of you got it, but that's fine. LLMs can reason wide ranging topics, but their knowledge is limited to public data. Okay guys, see, LLMs would not know my company data. How will they know? That's not on internet, right? So if you want an LLM to answer queries on the basis of your data, that's essentially RAG application. Okay. If you want to build AI application that can reason on private data or data introduced after a model cutoff date, you will need to augment the knowledge of model with the specific information it needs. Okay. So if you wish to supplement the LLM knowledge with your data, right, because it needs to answer on your data, so that is where everything lies, right? A lot of applications in organizations are essentially RAG only. Now the thing is, a typical RAG systems conducts of two main components: indexing, a pipeline for ingesting data and indexing it, and retrieval and generation. Okay, that is okay. You will understand everything if you will see the code, but just understand this is the flow. You have a lot of documents. Okay, you split that documents into small chunks. Why do we do so? We split documents into chunks because, see, one is the model's context length, right? Suppose you have a very big 200-300 page PDF, so you cannot just throw it entirely into the prompt, right? Because that would increase the context length. Also, these days context length is also increasing, so you can try out those things as well, but it's better to just split them into chunks. Then those chunks would get embedded. I have had a session of vector embeddings as well. And then once those embeddings are created, you store them into a vector database, and whenever the user queries, so I'll show you one image. I'll just see, someone might have created that image. Let me just Google it. RAG LLM. Do Databricks have a great image? Yeah, so I think this is a good image. Let me just open my pen as well. So see guys, there are so many datas. Okay, so what we first do is we split data into chunks. By splitting data into chunks, it essentially means we are breaking them into parts and those are being stored. Okay, then what is happening is essentially a user is doing a query: how can I track Databricks billing? So what it is going to do is that this query would be here. What they are doing is basically, essentially, I think this is their own system. This is not the general system. Let me just close the pen. It's fine. No worry. I'll show you one image of RAG. Don't worry. Mm, I think this is a good image, I guess. Let me open this image in a new tab. Yeah. So see, the client, we are asking a question. Okay. Now what is essentially happening is, first that question is going to go to your vector database. Let me just minimize the screen as well. Okay, it's not happening. Let me see. Okay, it's frozen. Let me just close the pen and let me minimize this. Okay, why it's at 175? Yeah, now it's fine. See, you have a client. What you are essentially doing is you're throwing a question. Okay, now this framework, okay, this framework is nothing but this is LangChain for the time being. This question would have some similar text in the vector database. Okay, so based on that search, a similar text would get generated, that is known as contextual data. Contextual data would also be sent to the LLM, plus your question would also be sent to the LLM, and then the LLM will answer. Okay, so what essentially is happening is that your question will first go to the vector DB, relevant information would be extracted, that would be given to an LLM, plus the question also would be given to an LLM, and then LLM will generate a response. It's simple, guys. Okay, let me again explain you. If I can find any better image also, we can see that as well. I think this is also a good image. See, the user is asking a query. That query is getting embedded. Those embeddings are being searched into the vector DB. From vector DB, you are having retrieved context. This is basically on some similarity that is going on. It can be on cosine similarity and other similarity as well. So you're essentially, there are a lot of similarity things. Okay, cosine is one. You have word based similarity as well, you have semantic similarity as well, you have hybrid as well. So yes, there are a lot of things by which we can compare similarity between embedding of your query and the data which is in vector DB. But for the time being, just understand that hey, similar text is going to get retrieved. That text plus my query is going to be sent to an LLM, and then an LLM is going to generate response. I think this is a great architecture. So simple, your query would get embedded, that embeddings would be then uh, given to the vector DB. The vector DB based on this embeddings would generate a similar context, and on that similar context would be given to an LLM plus the query and then a response. So simple. So now let's try to build this LLM application. So yeah, let's just try to build this application. So first of all, let's install, we'll create a application using LangChain only. So essentially, see guys, this is the PDF that I'm using. It is a research paper. Okay, this research paper is AI for handball, predicting and explaining the 2024 Olympic Games with deep learning and large language model. So these people I think this guy had written this research paper. So I like this research paper. And the thing is, let's just try to see also that was the result correct or not. Even I don't know. So in handball victory for France or Denmark, they were predicting. So let's just see in men only, right? Few nations will for previous for men, yeah. So this research paper is predicting France or Denmark would have won for men handball. Let me just see who won. Men handball Olympic result 2024. Okay, so Denmark won the thing, and this research paper also predicted that Denmark is going to win. So yeah, they got it right. So they leverage deep learning and all to predicting. So for predicting, so you can also try out something of those kinds. So this is the research paper. Now obviously an LLM wouldn't know about this. So first I'm installing all the libraries. Then this is a great feature. Okay, on Google Colab, wherein you can store your API credits or API credentials, and then you can just load them in your runtime using this snippet of code. Then we are installing the required libraries. So see guys, here what I have done is, here I have uploaded my PDF. So step 1 would be loading the PDF. Okay, so now the PDF is loaded into our system using PyPDF. Then what we are doing is we are splitting the text into chunks, as I explained you. Okay, here the first step of creating a RAG application is splitting them into chunks. Okay, so for that we are using recursive text splitter. Okay, it's just a way of splitting text. So essentially we had a PDF, we extracted text and all. Now we are splitting that text into smaller and smaller chunks. Why we are doing this? As I explained, guys, this is very important, since if you won't store your data into chunks, then uh, efficient retrieval would be difficult. Secondly, if the context length is too high, how would the model perform? Okay, so even it is also mentioning the same things. Okay, that it allows more precise retrieval of relevant info and token limits. Okay, then we are just splitting this up. Okay, and then we are just basically applying splitter to our document. This is just a snippet of code in which the chunk size is 1000 and chunk overlap is 200. So I guess this is not, guys, very difficult, just understand. So what is chunk size? Maximum number of characters in each chunk, and chunk overlap is just the overlap, right? Once I've created something from 1000 uh, characters, so in the next chunk it will have 200 characters from the previous chunk. Okay, so we have defined here the text splitter, and then we are applying it on our set of pages. Okay, so we have done this. Then as I said, guys, post doing it, you need to convert it into embeddings, right? Once you have converted this stuff into embeddings, then you would store into a vector DB. Here we are using Chroma DB. So if you would Google, and you will see Chroma DB. So guys, this is a vector database. Okay, this is a open source AI database, so you can read about it. Okay, but for the time being we are using it in memory, so we don't need to worry about too much, but yeah, it's good to know. So we are storing it into our vector database, which is Chroma DB. So let's just run it, and it is using Google embeddings model. Okay, so we had a PDF, we extracted text, we splitted that text into chunks, and now those chunks are being converted into vectors. Now those vectors are being stored to vector DB. Just understand, guys, we have done these 3 steps. I had that PDF in which there was a lot of handball related information, how AI can be used for handball prediction, and it got it right as well. So we have basically taken that PDF, extracted the text, split it into multiple chunks, and then we have embedded into embeddings. We have converted those text into embeddings, and we have stored it into vector database. Then, guys, this step we are doing in almost every video. We are just defining an LLM, and then, guys, we are just creating a retrieval QA chain. So what is a QA chain? See, guys, this is important. So in LangChain we create chains. Okay, so this is a QA chain. So what is retrieval QA chain will do is that it's going to take an LLM. Okay, it's going to take a retriever, and then it's going to return source document. So what this piece of code is doing is we have created a chain so that my LLM would answer based on the retrieved, or basically based on the similar context which it was able to get from where, from my vector DB. Okay, so this is the advantage of using LangChain. Otherwise I'll have to write a lot of code. So just have a retrieval QA chain where it has LLM defined and just your vector store as retrieval. So then your LLM would tend to respond based on the similar text that is being generated from vector DB. And then, guys, this is just a simple code that will give you question and answer piece snippet. I think you can understand. We are just calling the QA chain. So the question was, what is the main topic of the PDF? The main topic of the PDF is using deep learning and LLMs to predict the outcomes of 2024 Olympic Games handball tournament. So it got it right. So see, guys, how we made our model to answer on our personal public, on our private data. So let me explain you once again everything what you need to know. So see, guys, and guys, this is important. This use case you will implement on a lot of layers. Okay, you can go to any organization, they are just building RAG application only. Then you can explore from yourself as well that what's more in RAG. For a beginner, this much knowledge is enough. Okay, let's just revise the lecture. So you have a query, user will come and write query, nothing major. Those query would get converted into embeddings, and we'll have a vector DB. So now I had my private data, I converted it into chunks, I converted those chunks into embeddings, and those embeddings were stored here. Now queries got converted into embeddings. Then my model came in over here and found, okay, this is the relevant document, and all of them was parsed to an LLM along with a query, and it got me the response. Simple. And the next thing to remember is that we are using LangChain, and essentially by leveraging LangChain I can create something known as a retrieval QA chain, which will force the LLM to reply based on the retriever. Okay, this retriever allows semantic search over document embedding, so that similar text would get extracted and it will respond based on that. Okay, so guys, this was a simple explanation for RAG, and I guess guys, since we are trying to cover and complete the course, this much knowledge is enough. Rest, whenever you want to build something, explore. That's the only thing. You cannot be an expert in all fields. You know everything about RAG, you know everything about fine tuning. There is no one who knows everything, and even people who do research have specific niches of research. Okay, someone is good at NLP, someone is good at computer vision, so they have their own niches. So always pick your niche first. But you guys want to crack jobs, or you want to learn AI engineering and build products or do something for that matter, then first having a good outlook of, hey, what's around me is very important. That is why this course is there. This is short, crisp, concise, and this covers 80% of what you need to know, which is more than enough. Okay, so thank you guys, have a great day ahead.